everyone. Welcome to this new episode of our Student Spotlight series where we are able to showcase some of the work our past students have done. I'm Charlotte, one of the outreach coordinators here at CCIR, and it's our pleasure today to have Anthony with us, who did our one-on-one mentorship. So, firstly, Anthony, can you just introduce yourself? So, tell us where you're from, what year you are in school, and then what made you seek out CCIR.
Yeah. Hi, my name is Anthony. I am from Singapore. I attend Singapore American School, and currently I am in grade 11. The reason why I seeked out CCAR is because I wanted to do more or expand my knowledge about research papers, right? Like my school has these like research competitions, however, usually we make them out of like Google Docs, for example. And I want to experiment beyond just like writing on Google Docs or like just using basic experimentation, right? I want to go beyond that, and that's why I seeked out CCIR.
Okay, nice. And then can you give us a brief overview of what your course was about?
Basically, my course was about how electric fields could be used inside jet engines to improve fuel air if mixture efficiency. Basically, what that means is that using electricity, my research paper was about how we could lengthen the duration of which kerosene stays within the jet engine, such that the fuel and air mixture is better, such that there's better combustion, better efficiency, and so on.
Interesting. And then what kind of made you think of this topic? Was this an interest you had before CCIR?
To be honest, this project idea was kind of like pivoted by my mentor. Before CCIR, I was interested in physics and aerospace, and that's what I think kind of led me to my mentor. And basically, my mentor shifted my focus from the whole of aerospace into looking specifically into the jet engine itself, because my mentor had prior experience with like improving fuel air efficiency within jet engines and such.
Okay, interesting. And so did you have experience with aerospace or physics or engineering before starting CCIR, like in general?
Engineering wise, I was in my school's robotics team, FRC, and previously I had already taken, I mean, this year, right? I would taken physics C, and last year I took physics one. So I think in that sense, yeah, I took some courses that helped me in my CCIR course.
Okay, nice. And then to get into your specific research paper, so you've already given us a little bit of an overview. Can you walk us through how you decided on this topic alongside your mentor?
Basically, to this when deciding on my research idea, how we kind of narrowed it down was by beginning of which like we first saw like what I was interested in, right? I was more interested in how airflow works and how airflow impacts how airplanes like fly, how air is, and I was mainly interested in airflow. And from there, my mentor basically kind of like helped me guide through like which parts of the plane I was most interested in. And that turned out to be the jet engine itself. And from there, we basically just, fortunately enough, my mentor had experience with jet engines, so it was easy to go from there. And that's how I landed on my research project.
Okay, nice. And then in terms of your research methods and process, can you tell us what type of research you conducted and what the process of finding data and analyzing that data was?
But could you repeat? So you're asking how I conducted my method?
Yeah, what your research methods were and what that process was like for you.
Mainly how I conducted my research was through code. I use Visual Studio Code and Matplotlib to like plot my data and to visualize my data. How I went through with my project was by simply starting off simple, right? My professor already had some previous code I could use. And basically what that code was just showing how an electron or a droplet of kerosene flowed through an engine, right? And then from there, I began to implement more complex equations, more complexity. For example, I included like a Rayleigh limit. I included more physics, for example. I instead of just having one kerosene droplet being shot out into the jet engine, what if there are two, right? What if there are four, right? And that's what I did. And further on, that's how made it more complex, made it more complex, made it more realistic in that sense. And that's how I conducted my research experiment. And that's how I got to my findings and such.
Okay, nice. And then to discuss your findings, can you just walk us through what your paper found and what your big takeaways were?
One of the main things that I saw was how charged kerosenes, especially negatively charged kerosene droplets, behaved when exposed to both drag and electrostatic forces. I found that when interdroplet, I'm sorry, initially I found that without interdroplet interactions, the droplets followed relatively stable and predictable trajectories. However, when we introduce like repels, right? Repellation or some and things like that, I noticed how more erratic the kerosene droplets were and how unpredictable it became. And further on, by implementing fission into the equation, I realized how by introducing an electrostatic force that while I was able to make the kerosene droplets spread out more evenly or throughout or more uniformly throughout the engine, that it was more unpredictable and it was harder to track where they went.
And then for someone who might not be as well versed in kind of the field of aerospace, can you explain what that might mean in layman's terms or what the importance of that finding is?
To put it into simple terms, basically when when a kerosene droplet fissions, it just basically means it splits into two. And overall, what my research paper shows, or what it talks about, is that with an electrostatic force, two droplets, when they meet each other, they repel each other. And then further on, when they reach the Rayleigh limit, they split and they continue splitting. Like you can imagine it like bacteria multiplying like by doubles, right? That's basically what my research paper is about.
Interesting. And do you think this was kind of what you were expecting to find, or were these findings surprising to you?
Honestly, it was half expected and half not. Originally, I was expecting these kerosene droplets to kind of group up with one another, right? While like I expected to group, sorry, let me reiterate. What I expected was that for some spots of the jet engine to have like grouped kerosene and some spots to have like maybe a less density of these kerosene droplets. With my research project, I basically saw like, oh, how very evenly they were split, right? Yeah, that was what I found to be very exciting and like new.
Nice. And then to move on to just kind of your general experience with CCIR. Firstly, can you tell us what your experience was like in the program doing a high-level research project like this as a high school student?
Generally, I found it both tough and fun. It was fun because I was able to do whatever I wanted, right? I had the freedom to choose which direction I went into, and my mentor gave me full support. However, some troublesome things was that since I didn't have much experience in this field, generally, I didn't know where to go, and moreover, I felt like time was a big issue since as a high schooler, especially in 11th grade, I had many APs to do and many tests to take at the same time. However, I think things still went smoothly because my mentor was readily available to like switch times in case I felt too restrained. And sometimes he gave me guidance on what to do next or like suggestions on what to find next, right? And I really like that.
Yeah, I think that's one benefit of the one-on-one mentorship as well, is that the timing is extremely flexible. So if you feel like you're falling behind or have an exam coming up, you can always kind of shift things around, which is definitely nice. And then in terms of the research process itself, what was that experience like compared to papers or projects you've done in high school otherwise?
I think papers and research I've done in school really felt 1D, which what I mean by that is usually it was just one experiment and seeing the results of that, right? Oftentimes the research was just simple and it was linear. However, compared to CCIR, I felt that it was more multidimensional in the sense where one thing led to another and to another. And basically, the result of the project really heavily dependent on how far you're willing to go down the rabbit hole. And in that sense, I feel like CCIR compared to my school research projects was much more complex and engaging.
Nice. Yeah, it definitely is quite complex. And then my next question is about your mentorship and working with your mentor. So, for those listening, we really like to emphasize the aspect of mentorship in our programs as opposed to the traditional teacher, where our mentors don't just transfer information onto you as the student, but really guide you through your own discoveries and learning process, which you've discussed a few times. Can you tell us what your experience with your mentor was like as you moved through the first kind of teaching half of the course into the latter, more research-oriented half of the course?
I felt that in the beginning of the course, my mentor was really more friendly in the sense where we were just basically exchanging like greetings and like just figuring out what I wanted, right? Figuring out just simply put some fun things to like embark on. However, later on into the course, my mentor was more direct in a sense and more like how do you say more he just gave very much more information on how to do things. It was more like instead of like a student to teacher kind of situation, it was more like a researcher and researcher co-relationship. And in that sense, as time went on, I felt like my mentor became more and more of my partner instead of teacher.
Nice. Yeah, I think that's a great way to describe it, that the mentors, it really is a partnership between the mentor and the student. All right, and then just a few more questions for you. The firstly, do you think this course has given you any insights into your future? Has it informed or shaped how you think of your path moving forward at all, either in uni or in your career?
I feel like this course has kind of like had a big influence on my future, right? Initially, I was a bit hesitant between aerospace and mechanical engineering, but now I think I have a better grasp of what aerospace engineers actually do, what mechanical engineers actually do. And in that sense, I think I'm more directed into aerospace. Or since this project was heavily influenced by physics, I think I might also consider a path in physics as well.
I think that's great. It definitely is a benefit to be able at such a young age to have the privilege to figure out both whether you like the subject and maybe in your case even between a few subjects, but also whether you like research and if you want to pursue research later on is a really great kind of opportunity to see whether that's the path for you. And then my last question for you, what would you say to someone who asked you what the value of doing a project or a program like this is, especially for a high school student?
I feel like one of the biggest benefits of doing a research paper that expands beyond just school is that it opens up your eyes to what is exactly like reality, right? Oftentimes when you're in school, you're just enclosed by what your peers are doing or what your teacher gives you, right? Sometimes that might just be papers to fill out. That might be like simple like engineering projects, like building a robot that like moves around, for example. But I feel like by coming into CCIR, it kind of elevates what kind of things you might expect in your future, right? When I first came to CCIR, I thought I expected to be it to be some kind of like just a transitioning between from Google Docs to LaTeX or Overleaf. But it turns out it was a whole lot more, where we introduced graphing, where we introduced how different formulas combine into one and how it significantly impacts your research. And basically, to put it simply, right, you could imagine our school research paper to be building a Lego house. But if you were to do CCIR, it would be like building a Lego city. Yeah.
I think that's a great analogy. So that brings us to the end of our interview. Thank you so much for chatting to me, and congratulations again on your nomination to our Spotlight series.